Hi, Assalamualaikum warahmatullahi wabarakatuh. We from Group Power Puff would like to present about problem-based learning. So this is our members. First, Nurin Atilia. Second, Shazana Dia. Third, Nuraina Zafira and Nurhijana. So for project overview, the scenario is dataset given of 3-dimension parameters, which is length, width and height from 3 different operators. For objective analysis, using simple linear regression and R control charts, determine the outliers and create a solution to improve body parts production. The methodology used is we use the formula of S bar chart, R bar chart and S bar chart. So basically, outliers are observed from the data that is far from the square lines. Any point that is located further than 2 standard deviations are the outliers. From the graph, we detected 3 different outliers from sample 8, 23 and 43 in Excel and R programming. After using the formula of R bar chart and in Excel, we obtain the R control chart of width, height and length. From calculations in both Excel and R programming, we need to compare the results. Firstly, we need to compare the graph with different variables. For the x-axis in the graph, we use length, width, and height as independent variables. We choose to focus on length as independent variables as it has a high correlation coefficient compared to another variables. So from regression line comparison, so for the height versus length, the correlation coefficient is 0.17811. The correlation coefficient for width versus height is 0.110046. For height versus width, the correlation coefficient is 0.110046. The correlation coefficient for length versus width is 0.173244. For length versus height, the correlation coefficient is 0.178106. And for the width versus length, the correlation coefficient is 0.173244. So next, from R programming, we obtain the correlation coefficient for each graph. For length versus width, the value is 0.17324439. For length versus height, 0.178108. For width versus height, 0.110064. Width and length, 0.17324439. For height versus length, 0.17810448. And lastly, for height versus width, 0.11000404. So next, we move forward to the data set with outliers from length versus width and length versus height. Linear correlation coefficient is a statistical measure that indicates the strength and direction of the relationship between two variables. A correlation coefficient that is greater than 0 indicates a positive relationship between the variables. A positive relationship means that as the value of one variable increases, the value of the another variable also tends to increase. A value close to 1 indicates a high relationship between the two variables being compared. Hence, graph length versus width and length versus height have higher correlation. Next, we choose to focus on the graph length versus width and perform a simple linear regression test to determine outliers. Lastly, we compile new dataset with the outliers removed and we have a correlation coefficient higher than dataset with outliers. This is all due to when correlation coefficient higher, this means that the new line is better fit to the remaining data values. That's all from us. Thank you for watching.